So there are times when we want to be able to identify things in our local sky. Our local sky is basically a dome over our heads. If you go out to the horizon, spin around, okay, and look up, okay, you have just looked at your local sky. We can say that there's an object in the sky. For instance, this gal is pointing at the sun. The sun is located, it's got an altitude, it's got an altitude of about 60 degrees, okay, altitude of 60 degrees. The direction is southeast, okay, so she has identified the sun on her local sky. A few things about our local sky: we have something called the zenith, and that actually is straight up overhead, an altitude of 90 degrees. The meridian is a special point that goes passes through the zenith, going from due south to due north, or due north to due south, but that's your meridian. The horizon, of course, is at 0 degrees altitude. So let's see, I think that's all I wanted to say. So that is your local sky. It is helpful sometimes, like for instance, if you're going to catch the International Space Station, a pass, it can where you need to look in your local sky can be given for that. So I know we talked about like the astronomical unit, the average distance between the Earth and the Sun, and a light year and all that. But again, kind of back to our local sky, sometimes we want to say how big objects are or the distance between objects. And what we need to do then is use basically what we call the angle that object subtends, or the angle between two objects for a distance. So if you extend your arm, you have to extend your arm. Most people, when they extend their arm, if you hold out your fist, okay, that is 10 degrees. It's basically 10 degrees of an arc, 10 degrees of 360 all the way around you. Your finger, your index finger specifically, is 1 degree. Spanning your hands is 20 degrees. So actually this can be very helpful. So for instance, using that, if you hold up your, extend your arm and hold up your hand at night and look at the moon actually will, what we say, subtend just about a half of a degree. The moon will only be about a half of your finger. I know it seems like the moon should be bigger, but try it, okay? Try putting your finger over the moon with your arm extended. It's a half a degree. This actually can be very helpful, because if you're like me, you think, well, goodness, when the moon is like just rising, when the moon is close to the horizon, actually the moon looks humongous compared to when it's up at your zenith. Okay, but do this whole trick. Put your finger over it when it's low on the horizon, the moon, and then put your finger over it when it's straight overhead. And actually what you're going to see is that it's an optical illusion. Our eyes are kind of playing tricks on us. Try it. So a few other angles of interest. Right here, the Bowl stars, you recognize the Big Dipper in Ursa Major. The Bowl stars, actually we call the two far Bowl stars, we call them pointer stars because we know they point to Polaris. And so these point to Regulus, right, in the constellation Leo. But if you extend your hand, it will be a half of your kind of hand. Remember? Oops, sorry. It'll be a half of your hand because your whole hand is 10 degrees. We're not privy to it, but this constellation called the Southern Cross actually is 6 degrees from tip to tip. So a little bit about angles. Now I'm not going to, I don't have any math in this class, and some of my colleagues are like, how can you not do any math in astronomy? But just remember that full circle is 360 degrees. If we were going to take each degree and chop it up, it would be 1 minute. If we were going to take each minute and chop it up, it would be, sorry, I said that wrong. If we're going to take 1 degree, there we go, 1 degree and chop it up, it would be 60 minutes. If we're going to take 1 minute and chop it up, it would be 60 seconds. So that's how that works. And so here's a figure I believe from your textbook, that kind of shows the difference between degrees, minutes, and seconds. So honestly, this idea of angles doesn't only just go along with your local sky, but in astronomy, we definitely deal with angles here and there.